Hi, I'm Chris Hay, and I'm an independent consultant working with researchers from Illinois, Iowa, and Minnesota on a project advancing the conservation drainage practices of saturated buffers and bioreactors. One of the goals of this project was to develop some resources for farmers and landowners who have adopted these practices to help provide some more guidance on how to actually manage them. So we put together a series of videos, along with a printed guide and some online resources to assist with that. This video talks about the types of stoplogs and control structures used for managing the flow in saturated buffers and bioreactors. A separate video will then cover how to find and manage the stoplog settings for your practice. The stoplogs are what are used to set the elevation that water can rise to in the control structure to control flow through the saturated buffer or bioreactor. There are different types of stoplogs. So let's start by taking a look at those stoplog types used in the agri-drain control structures that are most commonly used with these practices. The standard stoplogs come in two sizes, 5-inch and 7-inch heights. So when we combine one of each, then we get a foot of lift. So depending on your control structures, your stoplogs will either have stainless steel or molded plastic lifting hooks. One special type of stoplog is the bottom board, which has a sticker that indicates that. The standard bottom board is always 7 inches tall and has a thicker gasket on the bottom to help seal the bottom of the control structure to minimize leakage. A special type of bottom board used for the outlets of bioreactors is called a drawdown plate. These drawdown plates have a small notch cut into the bottom to make sure the bioreactor completely drains once drainage is stopped, to prevent stagnant water in the bioreactor. They may come in either 5-inch or 7-inch sizes depending on your bioreactor design. One other special type of stoplog is called a V-notch weir. These are used for monitoring the flow rate through the control structure. So unless your practice is part of an active research or monitoring project, you're unlikely to have one of these. When they are used, the V-notch weir is used as the top stoplog. The stoplog settings, then, are the combination of stoplogs needed to get to the desired setting. In this example, there is a bottom board that is 7 inches, another 7-inch stoplog, then 3 5-inch stoplogs, which totals then up to 29 inches. Finding and managing these stoplog settings, again, will be discussed in another video. In addition to stoplog types, the type of control structure used also is important for understanding and managing the stoplog settings. So let's take a look at the most common control structures used for saturated buffers and bioreactors. 3-chamber control structures are most commonly used as the inlet for both saturated buffers and bioreactors. In a 3-chamber control structure, water enters from the field on the upstream side. Then there is a first set of tracks for holding stoplogs called the upstream or field side control. These stoplogs can be used to manage the water level in the field as part of a drainage water management plan. However, for most saturated buffers and bioreactors, this will not apply. These can still be useful if you're doing some work on the buffer or bioreactor and want to temporarily shut off the flow, or if you're doing work on the field drainage system and you want to keep any sediment that might get flushed from getting into the inlet of the saturated buffer or bioreactor. Otherwise, it's a good idea just to keep a single bottom board stoplog in these rails to serve as a check for any sediment that might be in the drainage water. The second set of stoplog tracks then are the tracks used to manage the flow into the saturated buffer or bioreactor. So as the water reaches these stoplogs, it is diverted into the inlet for the saturated buffer or bioreactor. And when the capacity of the buffer or bioreactor is exceeded, water will then flow over these stoplogs to bypass directly to the outlet. So the stoplogs setting here are generally the most important to get right for making sure your practice is working as designed, as well as avoiding any drainage issues in the field. Most bioreactors then will have a second outlet control structure that controls rate of flow through the bioreactor. These outlet control structures generally only have one set of stoplog tracks, and newer bioreactors will have a drawdown plate as the bottom board for the outlet structure. And depending on the design, there may be additional stoplogs as well. Instead of separate inlet and outlet control structures, some bioreactors have a single 4-chamber control structure that serves as a combined inlet and outlet structure. In a 4-chamber structure, the first 2 sets of stop logs are the same as in the 3-chamber control structure. The first set of stop logs is the field side control to manage drainage from the field. The second set of stop logs then diverts water into the bioreactor inlet and bypasses excess flows. The outlet from the bioreactor then comes in below the second set of stop logs. And the third set of stop logs controls the rate of flow through the bioreactor. So thanks for watching. Hopefully this video has given you a better understanding of the different types of stop logs and control structures used in bioreactors and saturated buffers. In another video, I'll cover how to actually find and manage the stop log settings for your practice. Check out the other videos in this series as well, and visiting the Conservation Drainage Network at conservationdrainage.net for more information and resources to help with managing your saturated buffer or bioreactor.